In this video lesson, we're going to be calculating the area bounded by two curves here. So the area between f at x and g of x, and let's assume that f at x is above g of x. We can view this area here as the difference between the area below f at x, this region here, and the area below g of x, this region here. So if we were to subtract these, we'd get what's left over, this area here. And we have formulas for this. In video lesson 1, we went through many examples, and we use this formula. In this example, the area below f at x would be, from a to b, would be f at b subtract f at a. Subtract, now in this area here below g of x would be, from a to b, would be g at b and minus g at a. And I use uppercase letters for the antiderivative. So it's double the calculations, but I'm going to show you something. I'm going to regroup this. I'm going to group f at b and the g of b here. So f at b minus g at b. So group it that way. And I'm going to group f at a and g at a. So why did I do this? Why did I regroup it? Because now I'm going to define a new function h at x, which is going to be the difference between f at x and g of x, provided f of x is above g of x. This new function will be the difference. And the antiderivative of this new function will be f at x minus g of x, all uppercase because these are all antiderivatives. So the area now, the area at b can be calculated using h at b minus h at a. And I'll show you how this simplifies things just a little bit in the next few examples. In this example, we want to determine the area between the curves y equals x squared plus 1 and the straight line y equals x from x equal 1 to x equal 3. So I have a diagram here. I have y equals x squared, which is above y equals x, and bounded to the left by 1 and bounded to the right by 3. So this is the region we want to calculate. So we are going to define h of x as the difference between f at x minus g of x, and f at x comes first because it is above g of x. So we have x squared plus 1, and we're going to subtract x. So there is your h of x. Sorry about that, it was pretty messy here. Let me just fix that. The antiderivative now, h of x, would be 1/3 x cubed. The antiderivative of 1 is x, and the antiderivative of x, you add 1, divide that out, so minus 1/2 x squared. So now the area at 3 will equal h at 3 subtract h at 1. And h is this cubic function. So there's a lot of calculating here, so let's get to it. 1/3 of x, or 3 cubed, plus 3 minus 1/2 of 3 squared, And then we have to subtract h at 1. It's 1/3 1 cubed plus 1 minus 1/2 1 squared. Okay, so that will be our area. Let's figure it out. Starting up here, 3 cubed is 27 divided by 3 is 9 plus 3. 3 squared is 9 divided by 2 is 9/2. Subtract. 1 cubed is 1, 1/3 of that is 1/3 plus 1. Then 1 squared is 1 times a half is a half, so minus a half. Let's get rid of the brackets here, so 9 plus 3 minus 9/2 minus 1/3 minus 1 plus a half. So let's add all these numbers up here. 9 plus 3 is 12, minus 1 is 11. Then we have negative 9/2 plus 1/2 is negative 8/2. And negative 8/2 simplifies to negative 4, so that's 11 minus 4, minus a third. So 11 minus 4 is 7, and we still have to subtract a third from that, and we get 6 2/3. So this area here is exactly equal to 6 2/3. Okay, next example, we want to determine the area between y equals x squared and y equals 2x minus x squared. And I have a diagram here. And as you can see, we have x squared here and 2x minus x squared over here. Now, I didn't give you left and right bounds here. Because from the picture, we have the region that's bounded between the curves. And you need to know which curve is above. And in this case, the 2x minus x squared is above, and x squared is below. Now you don't know the left and right bounds, although from the picture it's obvious. The left bound is 0, and the right bound is 1. But that's because I gave you the diagram. Now, if you don't have a diagram, you have to figure out where these two curves intersect. So where do they intersect? Well, we have a system of equations here. We set them equal to each other. X squared equals 2x minus x squared. Let's bring everything over to the left side of the equation. We'll get 2x squared minus 2x equals 0. And we'll factor a 2x. And we're left with x minus 1. 0. So we have a case 1 and a case 2. Case 1 yields x equals 0. And case 2 yields x equals 1. So as you can see, that's what we have in the diagram. Left bound 0, right bound 1. So from this picture we know 2x minus x squared is above x squared. So our new h of x function will be the 2x minus x squared, and we'll subtract x squared from that. Okay, so let's simplify that a little. We have 2x minus 2x squared. And the antiderivative h of x would be antiderivative of 2x. We add 1 to the exponent, divide that out. That's x squared. Here we add 1, we get 3, and divide that out. That's negative 2/3 x cubed. So the area 1 is going to equal h at 1 subtract h at 0. let's figure h at 1. We'll substitute 1 squared minus 2 thirds 1 cubed. And we want to subtract h at 0. We'll substitute 0 squared minus 2 thirds 0 cubed. Okay, so let's work this out. 1 squared is 1. 1 cubed is 1. 2 thirds of that is 2 thirds. And this is 0. So we're left with 1 minus 2 thirds, which is exactly equal to 1 third.